Next up, I'm going to introduce someone named Robert Van Voorhees to talk about how Kubernetes can scale to support an enterprise. Robert.
Thank you, Aaron. I'm Robert Van Voorhees. I'm a staff solutions engineer at VMware Tanzu. I'm here today to talk about achieving value when adopting Kubernetes and Kubernetes-based services across your organization. So we've already heard from the U.S. Army, and we've heard from Aaron about software eating the world. We know that the Department of Defense and U.S. Army need to increase their digital proficiency to achieve digital overmatch in emerging cyber conflicts or wherever the world of war might take us in the future. We also know that the Army Software Factory is trying to improve regular soldiers' lives and equip them to be able to do their jobs better, whether it's improving their ability to do something as simple as time cards or getting mission data, or to bring to the fight new capabilities rapidly and change those capabilities to meet originally unforeseen needs. A lot of the high regulation requirements like NIST 853 or in the DoD, the Secure Technical Implementation Guides, also known as STIGs, and Secure Requirement Guides, also known as SRGs, make this very difficult. Elsewhere in the public sector, we know we need to improve our digital infrastructure, reduce the toil necessary to meet emerging cyber requirements, and we want to improve our supply chain to have more confidence at bringing new technologies. And as many people have mentioned so far, we want to improve our developers' productivity. Public sector organizations are some of the largest companies in the world, employing millions of soldiers, government civilians, and contractors. So when we say we need to scale this across the organization, it's going to be a really big organization we're going to try to scale it across. And that is very difficult usually due to, as Vito mentioned earlier, the dependency on contractors or the churn of government civilians leaving, which creates this tribal knowledge and oftentimes bespoke software processes across different pockets in the public sector. So the last one is that the government operates in some incredibly unique environments. And when I say incredibly unique, I mean not just the classified networks or the top secret networks, but the Army at the edge or disconnected environments, or the mobile environments, or some of the crazy requirements that come up with these inconsistent environments. So how can we approach this reality with a strategy to identify these points of friction and overcome them? So we want to move fast without sacrificing security or stability. And we need to scale our software competency and capabilities for our developers. So what we're going to try to do is adopt something called a platform strategy. So believe that software, when properly applied towards the critical obstacles in the software development process, we can accelerate those software development cycles and consistently improve multiple facets of bringing software into production. Critical obstacles might be creating an actual environment for developers to work. I know that across the DoD and other public sectors, sometimes it can be incredibly difficult just to get a development runtime installed on a laptop that a developer is supposed to use, or to compile that software in a portable manner. It violates STIG requirements to install Docker onto a laptop, or requesting certificates or exposing correct ports in the DoD's massive spanning networks. All of these are examples of points that take extended durations of times to accomplish and are solvable with a Kubernetes-based environment. The strategy is about identifying these points along the road to production, weighing them to determine how critical they are and how often they are actually obstacles, and then attacking them with a service that can be automated and eventually flipped to empower developers to meet organizational needs. By leveraging this software automation in a repeatable manner, and then enabling access to the software through intent-based exposable APIs or web interfaces, we can create a self-service environment over time that can continually improve and integrate into larger software ecosystem. This ties back to the need to scale it, not just across teams in a single organization, but also across the larger community an organization might be part of. By keeping this software automation as a suite of interconnected services, forming a single platform to enable developers. You need something you're working towards each time you apply this strategy. You can't just collect all the technology and hope it magically installs itself and connects itself to achieve an outcome. Just installing Kubernetes won't make you DevSecOps. You should have something in mind to apply this strategy, even if it's taking an existing piece of software and improving it. That improvement might be for security and maintainability, or just moving it from one very restrictive environment to one more standardized and portable. That outcome should really be something you can explain the benefits of doing. And then as something that becomes a very tough point in the public sector, you need developers, and you need the ability to influence how those developers work in your organization. That's as I mentioned, and as Vito mentioned earlier, that can be really difficult. A lot of times the contracts aren't worded in such a way that the government can actually influence their development process. And oftentimes it's worded in such a way where the contractors can actually develop their software somewhere completely out of visibility of the government, and then just sort of deliver the final product. You need to work within the constraints of that contracting mechanism to actually have developers that are willing to apply this platform strategy with you. So now we've created this platform strategy, and we're going to use it as a guiding policy to evaluate the tools and individual capabilities that meet the needs of that path to production we're going to be walking on with the thing that we've identified needs to get into production. And this was critical for the US Army because we're using actual US Army soldiers, the owners and maintainers of this platform, evaluating that technology and applying it so that we're not just solving the outcome we hope to achieve, but we're enabling and training the soldiers along the way so they know why it's an axe, why it's a chainsaw, and where the wagon's spare wheels are. This also avoids the if you build it, they will come mentality, and gives you outcomes to measure tools against real scenarios. So the US Army identified a container-ready application leveraging a thread of tooling for a given design pattern. What that means is that they had something that they knew was achieving an outcome. They had something they knew was of value to the U.S. Army and had a user base that was excited to use their application. And they knew that they had a very narrow scope of how that application was built so that they could walk it to the path, walk it to production, and validate each step along the way. That also allowed them to focus not necessarily initially on the development of the application, but sort of everything that developers often forget happens when you finish sort of coding the individual application. So how do we get it into a container? How do we get it into these different inconsistent environments? How do we get it with the necessary certification to run in production? How do we actually expose it out to users? Where are the users living? What devices are they using? How do they connect back into this application? So while we're walking through that path, we're validating these tools, following that guiding policy of a platform strategy, making sure that those tools can be repeatedly applied, can scale, and can eventually be flipped to actually empower the developers to leverage it themselves instead of doing some kind of IT-based ticketing system. So once we walked through that process the first time, we then started looking at the second application. So the second application now was not an existing container-ready application, but instead was something going from a fresh new idea using a very similar design pattern with an additional need for more services. So now only the new services are required because all the existing capabilities we had for that first application were still there. They could still compile the application the same way, get all the same sort of dependencies. They were still containerizing it the same way, moving it into the environment. They didn't have to recreate the wheel with the second application. What the Army was able to do is embrace these initial limitations as a means to focus on these single design patterns and not boil the ocean. All right, so now we know we need to get into production. We know that we have a strategy that we're employing to get into production. We have a guiding policy to inform that strategy when we're looking at our different tools. So why am I talking about all these services we need to validate? Didn't we start by installing Kubernetes? So Kubernetes provides a common substrate to enable capabilities to integrate into a robust industry standard approach that has taken the cloud native landscape by storm. As Craig mentioned earlier, the Goldilocks form of abstraction. So it offers more than just a container orchestration. It exposes a whole lot of the capabilities from the underlying environment. One of the side effects of tying into all of that native capability of the environment you're running in is you have to actually configure it, not just for security and compliance, but also for actual integration. Oh, great, I want to create a load balancer in the Kubernetes world. I need to actually be tied in to the underlying environment, whether that's vSphere, Azure, or AWS, to actually invoke the creation of that necessary load balancer. And that's hard work. On cloud providers, that involves setting up the necessary identities and roles to provide least privilege. It means you need to actually understand the network environment you're operating under, and in the DoD, those network requirements are often isolated and locked down in basic private networks that have their own unique networking quirks that might not align with what a lot of industry best practice documentation or published documentation on how to use those cloud environments actually works. You go into it expecting your load balancer to spin up, and then suddenly you can't even access it because you're actually sitting behind a completely different network that is Doden or Nipper. And that also ties down just to the actual storage. So if you want to use storage in your Kubernetes environment, you have to actually understand what the services provided in that environment are, whether it's the file systems on AWS that could be Elastic Block Store, Elastic File Store, or if you're in a vSphere environment and you want to access one of the many different partners that provide storage in those environments. And then, even when you're done with just sort of the technical capabilities, you run right into the wall of those earlier mentioned STIG and SRGs that have to take into account encryption, audit policy, network requirements, whether your VMs are talking to your VMs or your pods are talking to your pods. And here's where properly configured capabilities like Antria are necessary for meeting not just Kubernetes actually works level, but Kubernetes can be accredited level. You also need a place to store all those containers into a registry, which is where harbor and distribution come into play. The US Army needs to securely store and house all of its own containers and cannot expect to go out to the internet or even other DoD networks in each of their environment it has to get a different container. And then you also have to think of things like how are developers authenticating to the Kubernetes cloud clusters in that cloud environment. And then we go back to that earlier mentioned guiding policy. Do they need to? So for the first two applications that the US Army did, we identified that wasn't actually a critical step in the process. There wasn't a lot of toil lost by developers actually accessing the Kubernetes clusters. So they didn't do it. So while technologies like Pinniped are really cool, it was not on that first narrow scope path to production. So the capability was delayed. You're still able to meet all of your STIG and SRG accreditations, but you take that really cool piece of tech, put it on a shelf, and say, someday we're going to get to you when that use case comes up and we need to have that developer access, but not today. So great. We've gone through this lengthy list of technologies to actually get Kubernetes to run. We've gone through it again to get Kubernetes to meet the necessary accreditation and security requirements of our environment. How do we do it again? How do we upgrade the underlying VMs? How do we meet our patching needs? This is where the US Army adopted a multi-cluster strategy with Cluster API. So by taking everything we did to create that secure and compliant Kubernetes cluster, we turned it into a repeatable process spanning multiple networks and environments. We were then able to, in minutes, provision a brand new Kubernetes cluster that met SRG and STIG requirements. So that means that your Kubernetes audit is turned on. It's properly configured to send the logs to where it needs to send the logs. Encryption's turned on at the VM and underlying etcd level. Some things were turned on that weren't supposed to be on, and so forth. Some accounts existed for certain scanning software to properly work, and some ports were closed and some ports were open. All to that very, 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 very long list of compliance requirements that we see in the highly regulated public sector. So that means now we're done, and we've created that cluster API process. All the VMs have all their CVEs patched, and each cluster across every environment rolls those new VMs twice a month to make sure no CVEs are fixable or exploitable. The VMs themselves are stigged out, have FIPS compliant kernels. All of the underlying VM audit services are turned on to meet both the operating system SRG, the Ubuntu STIG, of which the underlying VMs are based on, the container platform SRG, and the Kubernetes STIG. And again, we're back to that. It's an empty cluster, and so it's still missing a few things to actually be able to Kubernetes. And so we bring in Carvel tooling. So when you install Kubernetes, you get basically that blank world where the networking is not actually turned on. So by using an automated process, we can install the other services that are necessary and need to be configured, like networking, like storage, like internally routable load balancers. Those are all set up and installed. So we have our cluster. We follow that path to production, talking to lots of different groups and different organizations. We found out who actually was supposed to get the logging, what the log formats were expected to be in, and where we could automatically deliver them. All of that knowledge done with the actual Army soldiers maintaining the platform are taken back, added into all of that templating and process to create those clusters and configured. So when we push a button, or and by we I actually mean when an Army soldier pushes a button, they're able to spin up a new cluster into an Army environment in a couple of minutes. That's not just Kubernetes installed, but Kubernetes installed, configured to the underlying infrastructure. The logging's properly set up to forward the logging to all the great organizations that expect logging to be in their wonderful formats that are government standard formats to do their necessary logging, retention, and other things. We have the necessary entry points to access our clusters. And at this point, those clusters are only accessible by the platform engineers because using our platform strategy and walking our path to production, we identified, you know what, the developers don't need to do this right now. So we didn't have that capability exposed out to NIPRNet. It's isolated inside of the enclave that only the platform engineers can access. That can actually fully accredit our environment up to this point. I should probably note that we've been talking to the security teams the whole time, but now we're actually ready for them to go in and look at the environment to make sure that it met the assess and authorize requirements. So for those of you that are in the world of NIST, which is many public sector organizations, this creates an inheritable model in the risk management framework where the individual development teams no longer have to toil with any of the stuff that I just talked about up until this point, and it's all established for them by a platform. And we know that this platform is actually driving a necessary outcome. We actually have developers that are coming to the platform to do something, and we have two applications in mind to bring onto that platform to achieve those outcomes so that we can actually say something's in production and being leveraged instead of trying to do a if you make it, they will come world. So we have a consistent environment. We have many consistent environments across the different cycles we need to exist in. And it's very super convenient that the Carvel process we use to install that networking and storage and alternatively routing load balancers is the exact same tooling that we can now point at the services that our developers need for everything above that. So now we have Kubernetes. We have all the things Kubernetes needs to fully take advantage of the underlying network. We're able to create a consistent environment for additional Kubernetes native capabilities. So we could go back to that first application and its journey to production, where we decided we are going to take a code complete application from source and bring it all the way into that production environment. And we're going to lay it on top of the inheritable model that we've created by going through all of that toil of installing and configuring Kubernetes in the Army's environment. So from code, you can't just take code and sort of jam it into Kubernetes and expect it to be successful. You have to actually give it a container. So we needed a way to securely create a minimalistic container that minimized CVEs and manual toil to maintain. So that's where cloud native build packs came in. It was able to take not just source code, but an existing code base and turn it into a maintainable container. We found building those containers consistently and patching them without interrupting the developers to meet the necessary cadence of upgrades that I mentioned earlier, with the VMs being rolled twice monthly, also was critical point of toil reduction. And probably more importantly, it accelerated the development process, since the developers now are no longer worried about Docker files or the other things that they need to do to a container to meet various hardening requirements in the DoD. They can simply write their source code, and the build pack will detect that it's a Java application, grab that necessary file, turn it into a container, and put it into that Harbor registry that we mentioned earlier. And they actually enjoyed it because it was integrated in the way a developer expected to be integrated, instead of them having to go out and research how to build their own Docker file. What is Docker? How do I use it? And all those other questions were not something they needed to struggle with. So we repeated this process that I mentioned for creating a container through a bunch of other different critical points along the first application's life. So we've created a container. How do I create different manifest definitions to put it into Kubernetes? How do I configure that those manifests so that they have the necessary ports exposed? And how do I take that configuration and apply it to what will later become our second application? Then we need to figure out how to expose that through a load balancer. Thankfully, from earlier on when we were accrediting and exposing tools like Harbor and cloud native build packs, we had already gone through the necessary steps to take a technology called Contour to make sure that it met all of the DoD compliance requirements and security needs for exposing only TLS 1.2 capability and storing and serving up necessary DoD certificates for our application, which could now be maintained by the actual platform team rather than developers. So the developers didn't have to learn about certificate signing requests, submitting those to regional cyber command or whichever DoD organization talks back to DISA to get actual DISA signed certs. Those certificates were able to just be installed and applied for the developer's needs. So our first application goes off into production, following through that CI/CD pipeline that Aaron mentioned earlier with static code scans, dynamics code scans, looking at OWASP vulnerabilities, all the other things that are part of a typical DevSecOps process. The cool part about all of those tools that I mentioned is that those tools went through that same platform strategy guiding policy to look at how they met the critical toil that developers had. Is this the right tool to fit in that place? And those tools themselves being Kubernetes native, since Kubernetes has become such a great industry standard, the platform team was able to take those tools and run them on top of their own clusters that were able to be quickly spun up to host the tools because we had already figured out that we needed that Kubernetes platform environment for the applications. We were able to reuse that capability to actually host the tooling for our development environment as well. So now when we have to do a patch upgrade for our source code repositories, we're able to roll not just the VMs for the source code repositories, but the actual VMs for the applications we're hosting. This creates significantly less toil because we're not sticking out and accrediting VMs or other kinds of infrastructure just for common services in the organization. We're able to still inherit and reuse all of those layers as we walk up the stack. So for the second application, we decided to get a little more complicated or a little more complex from a design pattern standpoint. The first application was actually, it was a great application that was able to achieve all the goals it needed without a lot of supporting services. But the second application coming through really needed persistence of data in a database. And it needed some other capabilities. But the need for persistent data in a database was to use Postgres. So Postgres, again, if you live in the NIST world or the DoD or SRG world, has a whole lot of requirements for secure and hardening it. It needs to have encryption turned on. It needs to pass hundreds or so different checks. Thankfully, using that guiding policy we had applied earlier to actually create not just the application itself, but the process to create the application, we had accredited and validated Postgres for some of our early tools like Harbor and GitLab. And so we were able to take those same templates and reuse them for the actual developer's application. We said, hey, can you guys use Postgres? And they said, yes, we want to use Postgres. That was what we were going to ask you we could use. And we were able to say yes, since we had validated and checked the templates and process for creating a database, we had created effectively a STIG and hardened database as a service within the US Army. So instead of having to go through more toil, we were able to effectively say, go make me another database in this environment. This environment is Kubernetes, so it's consistent with all the other environments that you've stood up in. Do you exist? And Postgres would come back and say, yes, we exist. So we're able to connect that up to the second application across all of those environments that the second application needs to live in, and it's able to connect into that Postgres database. Again, following that platform strategy and guiding policy to make sure that when we're looking at Postgres as a database, we're identifying, is this actually a toil reduction? Is this something that developers don't want to manage themselves? And yes, that was definitely the case with Postgres. So the other capability they needed to do was connect to a working single sign, single sign-on capability for users. So that's folks visiting the page. That's not developers. That's not the use case I talked about earlier. But now we actually have end users that want to connect in and authenticate to the application. So we're able to look at that service in the environment, and the platform team, the soldiers, the owners and maintainers of the platform, are able to look at and validate that capability for where it would tie into actually going into the application. And that would then be applicable to future applications that need to use that same single sign-on service. So we've created a database as a service capability. We've created a single sign-on as a service capability, not just for the developers to consume, but actual end users to consume as well. The next thing that we tackled was managing DNS and certificates internally, which I had mentioned earlier for the first application. Rather than having to recreate that, we were able to leverage it again since we had exposed it internally as intent-based APIs. our automation was effectively able to say, hey, are you creating a DNS and certificate for this application? And yes, it was. So we were able to leverage it again. So all of these capabilities are readily available now in the US Army's DevSecOps ecosystem. And it has that narrow focus, but it's able to start going more broadly, expose it to the rest of the US Army, using that guiding policy of a platform strategy. And it has a lot of tools and further tools that are getting added to that toolbox. And we're able to say that each tool has been individually validated and proven to work in that environment. So we're not just installing technology for technology's sake. We're able to actually say this piece of technology was a part of this effort that was tied to this outcome that we conducted for this application. So in closing, each of those validated and tested technologies that I talked about, installing into a Kubernetes native environment to meet the needs of the US Army and meet the needs of the DoD, SRGs, and SIG requirements, are options in VMware Tanzu. So each of these pieces has been combined to achieve outcomes for the US Army, and is continually improved and maintained in that partnership with VMware to make sure that the speed and agility that the US Army wants to maintain can be done for years to come. We hope that more public sector organizations will work with us to expand that community of cloud native software on Kubernetes and continue to bring more consistent Kubernetes substrates to other areas of the DoD, US federal government, state, local, and education across public sector.